some more rules of techniques for differentiation. Be sure to add these to your derivative rules list. The derivative of a constant multiple rule. If y equals f of x equals k times u of x, where k is a real number and u of x is a function, then the derivative, denoted by f prime of x, or dy dx, or y prime is equal to k, the constant, times the derivative of the function u prime of x. The derivative of a sum or difference rule. If y equals f of x is equal to u of x plus or minus v of x, where u of x and v of x are other functions, then the derivative, denoted by f prime of x, equals dy dx equals y prime is equal to the derivative of u of x plus or minus the derivative of v of x. Example 1.7.7. Find the derivatives of the following functions. A. Y equals 3x squared plus 5. We begin this by writing y prime. The constant stays put, and now we take the derivative of x squared, which means we bring the 2 down. We have x to the power of 2 minus 1, which is just 1, so we don't need to write that, plus the derivative of 5, which is 5 is a constant, so the derivative is 0. Therefore, the derivative y prime is equal to 3 times 2, 6x. Let's proceed to part B. F of x equals 7x squared minus 11x plus 14. To find the derivative, we begin by writing f prime of x equals, then using the constant times the derivative of the function rule, we have 7 times, and then we need to multiply that to the derivative of x squared, which is 2x. Then sum or difference, we'll do minus, the constant is 11, times the derivative of x is just 1, plus the derivative of 14, which is a constant, and the derivative of a constant is 0. Let's simplify, and we have f prime of x is equal to 7 times 2 gives us 14x minus 11. Part C. Y equals 2 times the cube root of x plus 1 over x to the 4th minus 10. Let's rewrite the first 2 terms of this function so that we have exponents that are all in the numerator. So we'll have y equals 2, and then the cube root of x can be written as x to the 1/3 plus, and then 1 over x to the 4th. Using rules of exponents, we can write this as x to the minus 4th minus 10. Let's take note that we have done no calculus yet. All we have done thus far is use the exponent properties of algebra. Now we're ready to find the derivative. Let's write y prime equals 2 times, that's the constant, then the derivative of x to the 1/3. We write the 1/3 as a coefficient, times x2, and the power is 1/3 minus 1. As a quick reminder, you need to do 1/3 minus 3/3, which will give you minus 2/3, plus the derivative of x to the minus 4. We write down the minus 4 as the coefficient, x to the power of negative 4 minus 1, which will give you negative 5, minus the derivative of 10, which is a constant, is just 0. Let's clean up the terms. We have y prime equals 2 times 1/3 is 2/3, x to the power of negative 2/3, minus 4 times x to the negative 5. Let's do part D. G of x equals 5 over x squared minus x. Let's rewrite the 5 over x squared so that the x squared is in the numerator using rules of exponents. We can write this as g of x equals 5 times x to the negative 2 minus x. Now let's use the rules for differentiation. We write g prime of x is equal to, the constant 5 stays put, the derivative of x to the minus 2 is, we bring down the negative 2, times x, the new power is negative 2 minus 1, which would be negative 3, and then minus the derivative of x is just 1. Let's clean this up, and we get that the derivative g prime of x is equal to 5 times negative 2 is negative 10, x to the power of negative 3 minus 1. Example 1.7.8, find the derivative of g of x equals the quantity 5 minus x cubed divided by x squared. In order to find the derivative of this function, we need to simplify first with a little bit of algebra, so we begin. G of x is equal to, and we'll separate the numerator terms, 5 divided by x squared minus x cubed divided by x squared. Let's continue to simplify some more using our rules of exponents. Then we get g of x equals 5 times, we can move the 1 over x squared into the numerator by writing as x to the minus 2, and then minus x cubed over x squared simplifies to x. Now we are ready to take the derivative. Then we write g prime of x is equal to 5, the constant stays put, negative 2, the power becomes the coefficient, times x to the power of negative 2 minus 1 gives us negative 3, and then minus the derivative of x is just 1. Clean it up a little bit. We get g prime of x, that's the derivative of g with respect to x, is equal to 5 times negative 2 is negative 10, times x to the power of negative 3 minus 1. Example 1.7.9. The demand for a certain product is modeled by the function d of x equals x squared minus 4x plus 7, where x is the price in dollars. A. Find an equation for the tangent line to the demand curve when x equals $3. Let's recall that in order to get the equation of a line, you need 3 items. They are the point on the line, 2, the slope of that line, and 3, the equation of the line. So let's begin by first finding the point. The point is an ordered pair, and we are given the x value already as 3. To find the corresponding function value, we evaluate the 3 in the function. That is, d of 3 is equal to, then where the x was, we write blank squared and put in 3, minus 4, open parentheses for the x and replace it with 3, plus 7. And that is equal to, let's see, 9 minus 12 plus 7, negative 3 plus 7, which is 4. So a point on the tangent line is 3, 4, and that is also the point on the function. Now we need to get the slope. And the slope for the tangent line is the derivative evaluated at that point. That is, we need to find the derivative of the demand function and evaluate it at 3. We first find the derivative. d prime of x is equal to, the power of 2 for the x squared becomes the coefficient, so we have 2x. 2 minus 1 for the power just makes it 1. And then minus the derivative of 4 times x, which would be minus 4. The derivative of x is just 1, so we don't need to write that. And the derivative of 7 is a constant, is 0. Now we proceed to find the actual slope. So we take the derivative function and evaluate it at 3, which would be 2 times 3 minus 4. And so 6 minus 4 is 2. We have a point. We have a slope. Now we need the equation of a line. Let's use y minus y1 equals m times x minus x1. Then, replacing the parts, we would have y minus y1 is the function value, which we computed as 4, is equal to m, the slope, which we computed as 2. Then we have x minus x1, which was given in the statement of the problem as 3. Let's put this in the slope-intercept form. So we have y minus 4 equals, distributing the 2, we get 2x minus 2 times 3 is 6. Let's add 4 to both sides, so we will now have y equals 2x at negative 6 plus 4 would be minus 2. Let's now consider the graph of the demand function and the graph of the tangent function. The demand function is the parabola, and the tangent is denoted by the dashed line. Let's observe that at the point 3, 4, the tangent line is increasing, and so that indicates that at that particular point, the demand is increasing. For the same problem, part B, find the point or points at which the tangent line to the demand curve is horizontal. Let's recall that in order for a line to be horizontal, the slope must be 0. So when we are looking for the point or points at which the tangent line is horizontal, we are looking for where the derivative equals 0. Let's begin by finding the derivative function. So d prime of x is equal to, for the x squared minus 4x plus 7, the derivative of x squared is 2x. The derivative of negative 4x is just negative 4. And the derivative of the constant 7 is 0. Now we set that derivative function equal to 0. That means we take the 2x minus 4, set it equal to 0, and solve for x. You get 2x equals 4, divide by 2 on both sides, and we get x equals 2. We then get to conclude that at x equals 2, the tangent line to the demand curve is horizontal. Example 1.7.10. Find the equation of the tangent line to f of x equals x cubed minus 6x when x equals 2. In order to get the equation of any line, you must have 3 pieces of information. They are 1, the point on the line, 2, the slope of the line, and 3, an equation form of the line. Let's begin by first finding the point. The point is an ordered pair. The x value is already given as 2. We need to find the corresponding y value using the function. So we will do f of, and use open parentheses as a placeholder for the x. Put in 2 is equal to, open parentheses cubed, so I'll replace the x with 2, minus 6 times open parentheses, so again I'll replace the x with 2. Solving, 2 cubed is 8 minus 12, and 8 minus 12 is negative 4. So the point of the tangent line is the ordered pair 2, negative 4. In order to get the slope, we must first compute the derivative, so we say m is equal to the derivative f prime evaluated at 2. We must compute the derivative first and then we evaluate, so let's find the derivative. F prime of x is equal to, for the x cubed, we bring down the power of 3 and make it the coefficient, times x to the power of 3 minus 1 is 2. And then we do the minus using the sum or difference rule. Then now using the constant times a function rule, the derivative of 6x is the constant 6 times the derivative of x, which is just 1. Now we evaluate this derivative function at the desired x value of 2. So let's write f prime of 2 is equal to 3 times the quantity, we'll put in 2 squared, then minus 6. Continuing, that'll be 3 times 2 squared is 4, minus 6. 3 times 4 is 12, and then 12 minus 6, which gives us 6. So the slope of this tangent line at the desired point is 6. We have the point, we have the slope. Now we need an equation form of the line. We'll use y minus y1 equals m times x minus x1. Let's replace some of the values. Y minus y1 we solve to be negative 4. The slope m we solved to be 6. Then x minus x sub 1 was given as 2. Let's simplify. Y minus negative would be plus 4 equals, let's distribute the 6 on the right hand side. So we've got 6x minus 6 times 2 is 12. Let's subtract 4 from both sides and we'll get y equals 6x. Negative 12 minus 4 is negative 16. And now we have the equation in slope-intercept form. Example 1.7.11. Determine the x value or values where the tangent line is horizontal to the function y equals f of x if the derivative of that function is given as f prime of x equals 3x times the quantity x minus 5 squared. Let's recall, a line that is horizontal has a slope of 0. Let's repeat that again. A line that is horizontal has a slope of 0. Now let's put that together with the derivative function gives us the slope. So what we are solving for is where the function f prime of x, that's the derivative, is equal to 0. Then we have 0 is equal to 3x times the quantity x minus 5 squared. Using the zero product property, we have 3x equals 0 and x minus 5 quantity squared equals 0. Solving for each of these factors, divide by 3, we get x equals 0. The square root of 0 will give us x minus 5 equals 0. Add 5 to both sides, and we get x equals 5. So the x values are at 0 and positive 5.